Okay, let's go to part two. Now this problem is going to look very intimidating, but I'm going to say right off the bat, if you take really good time and draw a really good picture, again, a picture where all the pieces make sense, all the lines make sense, all the angles make sense in the problem itself, it's really not all that bad. It's just something you have to kind of think about. So to keep wind damaged houses upright, workers often place long pieces of steel or wood against the house to brace or prop them up. That right there tells me I'm going to be dealing with triangles, because if I take a piece of wood and lean against the house, even if I'm bracing it, that's going to form a triangle with the house. So workers place a 4-meter brace against the side at a 47-degree angle to the ground. Let's stop right there and start our drawing. And so we're going to need a house. I'm not going to be fancy here. Oops, I'm going to be a little better than that though. Here is my house, at least a wall of my house. Okay, so I'm told that we have a 4-meter brace against the side of a 47-degree angle to the ground. All right, so that means we have this worker, and he sticks this piece of wood or piece of steel into the ground, and then he props it up against the house. We're told a couple things. One is 4 meters long, so I'll go ahead and write that. The other is that I have a 47-degree angle to the ground. Now, that's another way of just saying angle of elevation. And so what that tells me is that if I look at the ground, this should be 47 degrees. Very sneaky way to put that, but nevertheless, there's our triangle. And again, we can assume it's a 90-degree angle because it's up against the house, and we don't intentionally build houses crooked, unless you're a weird architectural guy. So the reading continues, then without moving. And now that's a really important part here, because he was here when he placed the first brace, and now he's not moving. He's just grabbing another piece of wood, sticking it to the ground, but now it has a different angle of elevation. Now it's going to go a little higher. Now this should make sense because, well, he needs to brace the house in more than one spot. Like one brace isn't enough. We're also told this is 66 degrees, so I'm going to zoom in here, mark that as 66. And we're also told that it reaches the very top of the house, and that's a dead giveaway that we're going to be asked to find that length at some point. And so now we have three questions. How long is a brace? Or no, how long is a longer brace? Because we don't know that right now. What is the distance of the house between the longer distance on the house between longer and shorter brace? And so we can start marking. We need to find x. We need to find the distance between longer and shorter brace. So we need to find this value, which is going to be called y for right now. And we also need to know the overall height of the house, which I'm going to call z. So it's a pretty complex problem. So let's develop a problem-solving routine first. So it seems to me that I have this red triangle, I have this blue triangle, then there's various pieces I need to find. But if you look at the blue triangle, that's not going to be a good place to start. I don't have any information of the blue triangle whatsoever. And at minimum, we're going to need an angle, which the blue triangle does provide for us, and a side length, which it doesn't. So the red triangle is probably going to be the thing we'll look at first, because we do have a hypotenuse. We do have an angle, which means I can pretty much solve completely this triangle, at least for the side lengths. Now, if you're wondering why that's really important to start with the red, because once I get the entire red, I should also have the bottom. And as soon as I have the bottom, I have the side length I was missing to solve the blue, and I think I can go from there. So let's get into it. Let's just jump into x first. Okay, so let me mark this 4x. So our routine is going to be the same here. Like we're going to have to compare some triangles. So reference triangle versus actual triangle. I'll try to keep that in view. And so we're trying to find values. Now it seems like all the values are going to be important. So let's go in here and mark this a little bit better. I'm going to call this one A, because if I'm picking 47 to be my reference angle, A seems to make sense. It's my adjacent. And I'm going to call this OP because, again, it's opposite to my reference angle. And so it looks like we're going to have to do a double solve here, but that's okay. So the first thing we're going to do is pick a ratio. 47 is my reference angle. Let's solve for A first, because I know I need that directly to get to X. And so A is my adjacent. I have my hypotenuse, so it looks like I'm going to look at adjacent over hypotenuse for a 47-degree angle, and make that equal to adjacent over hypotenuse for a 47-degree angle. So for the reference triangle, 47 is going to be on the right-hand side. I'm looking at adjacent over hypotenuse, so it's my first column. For 47, looks like 0.6 820. And the actual adjacent over hypotenuse I need to deal with is going to be a over 4. Now again, we're going to have to kind of decide how we want to solve this. I think in the previous video I did some cross multiplication. Here I'll do a little more direct algebra. Like if I have it divided by 4, multiplying by 4 on each side will get rid of the 4 on the right and give me a direct value for A. Okay, so 4 times 0.6820, which leaves me an A value of 2.728. Now, again, checking the reasonableness, if the hypotenuse is 4, about 3 seems okay for one of the legs. And also, that seems like a reasonable amount to kind of stick that first brace out. Okay, now we have the A value now. This is going to be 0.2728. I'm going to mark it here. Sorry about that. 2.728. Now remember, the whole point of finding the bottom is because it's actually shared in the blue triangle now. And if it's shared in the blue triangle, I can now solve for x. So now I'm going to kind of re-gear here and start this again. We're going to solve for x this time. So let's start with the reference triangle equals the actual triangle. And now since we're solving for x and we just acquired the bottom, it looks like we're going to rock adjacent over hypotenuse. But this time it's going to be for 66. So it's going to be adjacent over hypotenuse for a 66-degree angle. Adjacent over hypotenuse for a 66-degree angle. And again, doing this step is setting me up for success. I want to make sure I'm pulling the right values. So in my actual triangle here, I have my adjacent side, which is 2.728, over hypotenuse, which is x. And that's going to be equal to the value I pull off my trig table. Again, adjacent over hypotenuse for 66. That's the first column because I'm reading from the bottom to get to 66. And that's going to be 0.4067. Okay, so of course that represents the ratio of a triangle with the same angle. It's a similar triangle, but the ratio in this case of adjacent over hypotenuse. Now I'm going to solve. Now this one seems a little trickier, so I'm going to go ahead and cross multiply, stick that guy over 1. So I have 0.4067x is equal to the multiplication of 1 times 2.728, which of course, since it's times 1, we're good to go there. Okay, so now we just have to do a quick division problem. Okay, so those are gone now, and x is equal to, so divide by point. We get x to be 6.7076. Okay. Now, again, in thinking about this problem, it should make sense that it's that big because the initial brace, the one here in red, is 4. And so my new brace being 6.7076 meters, that seems to be okay. Now, we're not all the way done yet because it's several questions. And I'm going to go back and organize this at the end. But we now have found x to be this nice value right here. But we're asked that we need to find also y and z. Now I'm going to actually go out of alphabetical order here. I think it makes most sense right now to solve for z. And the reason why is because z represents an entire length of the big triangle, the blue triangle, and I already have 2 sides of it, so I have a lot of options which I can solve. I think for me, I'm going to go ahead and set up another trig problem. That actually is most efficient for me. Now you could use Pythagorean theorem here, but since you have trig at your disposal, why not use it? So looking at the big triangle, I want to find z, which is the entire length. Okay, from top to bottom. Okay, and so I have the hypotenuse to work with, I have the bottom to work with. Those are both numerical values that I found. Now here you have to have confidence in your abilities because neither one of these values were actually given to you, and so you have to kind of trust that you've done your trig up to this point accurately. Either way, I'm going to use 66 degrees again as my reference angle. And see, I'm going to have to pick the opposite, which is z. I think I'll just go ahead and pick the hypotenuse, the one I just found. So we're going to rock opposite over hypotenuse for 66, opposite over hypotenuse for 66. The actual triangle, looking at it right here, opposite is actually z, adjacent is 6.7076. And now I need the opposite over hypotenuse value for 66 degrees. Again, reading off the bottom, opposite hypotenuse will be my second column now. So it'll be 0.9135. Okay, and I wrote that in. You guys couldn't see it, but I already wrote it in right there. Okay. Now to solve for z, let's do cross multiply. I like that. And so, of course, I have z times 1, which will just give me z. And then 0.6076 times 0.9135. Boom. Which gives me z to be 6.1274. Okay, so z represents the entire length of the house. So we have 2 of the 3 parts we need. All we need to do now is actually just find y, and we are home free. Now to find y, let's again develop a little plan. Let's get some of these pieces out here. Okay, to find y is just going to be this piece from top to bottom. It's above the red triangle, but bottom of the top of the house. So if you think about how we're going to do this, it seems to make the most sense. We'll probably have a subtraction problem. So to actually find this little chunk right here, which I put in green, which is y, we're going to have to subtract z minus OP. Okay, so if you're now understand the logic here, examine the diagram. If I take the entire length, of z and then subtract off OP, all I should have left is this guy right here. Because pink plus green equals blue, so blue minus pink has got to be green. And that's the logic we're going to take on this problem. So that's what we're going to do. Let's do it. Okay. I already have z. I found it in a previous step. It's actually right here. What I don't have is OP. So what I really need to do right now is to stop and solve for OP. And so we're going back to our red triangle. Okay, again, we're going to start with reference triangle is equal to the actual triangle. Ratios, of course. We're going to pick 47 to be our reference angle because we're trying to find OP. I was given the hypotenuse off the break, so I'm just going to use opposite over hypotenuse for 47, and that's going to be equal to opposite over hypotenuse for 47. So now the actual triangle, of course, will be the OP divided by the 4. Let's go to our trig sheet. We need opposite over hypotenuse for 47. That's off the bottom, but now it's going to be the second column. So 0.7314. Now, one thing I hope you notice is that the algebra here really isn't too tenuous. Like once you get to this step, once you actually have like this proportion written, it's really just a 1 or 2 step proportional solve to get there. Again, I'm going to cross multiply, so I have the OP value equal to 0.7314 times 4. I'll do it off screen. And I get OP to be 2.9256. Okay, so if I come here, I now have this value right here. This is 2.9256. And so now I found z the previous step. I just found OP. Let's calculate our y. Okay, so our z is 6.1274. Double checking. We just found OP right here. Okay, so we're going to subtract off 2.9256, and that should equal our y. And so our y value, the space is actually going to be in between the two pieces of board, will be 3.2018. Okay, and so all the pieces are here. It's a little difficult to read. I know there's a lot of work kind of scattered over the place. So let's do the right thing. Let's rewrite all this. Okay, so here are our solutions. The long brace, which is our x, is 6.7076 meters. What is the distance on the house between long and short braces? Okay, so the difference on the house, which is our y value, we just saw down here to be 3.2018. And the house, which was our z value, is 6.1274 meters. Okay, so those are our three solutions. That's a rather long problem, guys, but it's a fair one, so be prepared, all right? So that's part 2. See you in part 3.